Hello, it's Professor Gibson. Welcome to video chapter 6, section 2 for Math 114 about growth and decay rates. Growth and decay rates. Okay, remember growth is what we call exponential growth, and we call decay when it's shrinking, right? Growth is when exponential is growing, decay is when it's shrinking. A couple different ways things are going to be given to us here. One, they're going to talk about annual growth, and this looks a lot like our the financial ones we've been doing, right? The compound interest, where the compounding is once per year, 1 plus r to the t. All right, only it's not being used. If this were the actual financial, we'd call this b a p and all that. So we'll use it in different settings, but it's essentially the same formula. R is the annual growth rate, B is the starting value, T is the number of years. If they talk about a continuous growth, all right, instead of annual, this will be the formula. E is a special symbol on your calculator if you're not used to using it. It should be, if you find the ln key, ln, it's usually the inverse on that. So if you do second ln, you can that'll usually be the e key. Or actually what it is typically is e to a power, and then it lets you put the exponent in. All right, so these two equations work out to have the same results if the various constraints, numbers, constants are chosen correctly. And they will do them both ways in the homework. All right, a little reminder here about the exponents. When r or k are positive, the way we've got this set up, these are growth functions. When r or k are negative, they're decay functions, is the terminology. Okay. So we will have to solve. There's some places where we'll have to solve. Like we'll be given something that looks like, with the continuous, we're going to have to convert it over to the annual. And what we'll do, I left this off here, so we'll solve for e to the k equals 1 plus r. We'll evaluate e to the k using the calculator, or you can do it in Excel, either one. The Excel for, let's say k is the number 3. In Excel, you type equals exp, put in a 3, and it'll evaluate it. In our calculator, we're going to go second, hit that ln function. It's a lowercase l in your calculator. Put in a 3 and hit equal. They'll get you, right? So that'll be e to the third in both cases. All right, so let's move on. Let's see how we'll do a live one. Okay, this will have all this in it. Population can be modeled by the exponential equation of y equals 280,000 e to the negative 0.0759, right? That's negative, so this is going to be a decay, right? This population shrinking. Times t, where t is years since 1990, y is population, complete parts A through D. What is the continuous decay rate per year? Okay, so the rate, remember, is just the k. It's this number right here. Since they've already said decay, right, and the population is decreasing at, get rid of the minus sign, so it's decreasing at 0.0759, 7.59%. What is the annual decay rate, not continuous? Right, well, this is that thing I was just talking about in that last slide. So what we do is you go, we have e to the minus 0.0759. I'm just taking that right out of the equation here. And I've got to make that be, the format for annual is 1 plus the rate. Okay? So in the calculator or in Excel, we've got to solve it. So in my calculator, I'm going to do second ln3. I'm not 3, but I'm going to do second ln, and then we're going to put this negative 0.0759. So second ln, that brings me up an e to the x function. negative 0.0759, hit enter, 0.9269. Okay, now we're solving for r. Subtract 1 from both sides. And this will round to negative 0.0731, and they want it as a percent, so move the decimal over 2, 7.31%. Remember here it's negative, right? Let's come back over here. The population is decreasing. All right, I've already got the decreasing built in, so we're not going to write the negative, 7.31%. Now, they want you to write it like this. Right, they've already given it to us with the EB. They want us to rewrite it. So the 280,000 stays the same. You'll notice they have that in all the options. What's happening here, you see the 1 plus r is this. See, that's what they want. They want that number, 1 plus r, to the t. So what you end up doing then is you got your original 280,000. Pull your 1 plus r from over here to the t, and then look for it, and there it is right there. Okay, last step. How many people will there be after 8 years? Well, so what I'm going to do, I'm just going to go ahead and use this one right here. And I'm going to plug the 8 in for the t. So 280,000, 280,123 times 0.9269. Hit the exponent key, right? And then instead of the t, I'm going to put in the 8. And this comes out 152, 553, 0.1. And so they're going to round it to the whole number, and it's just going to be the 152, 553. Okay, so there's not a lot of answers here, but there's quite a bit of stuff going on. All right, so let's go back to see what we did here. First, they gave us this equation with e to this power. You know, e to the minus 0.0759t. Then they ask us, what's the decay rate? Well, you need to know then you just pull that minus 0.0759 off. That's the rate. And since we've already got the word decreasing, we're going to get rid of the minus sign and just convert 0.0759 into a percentage. Then they want to know the annual rate. Okay, so we just did the continuous rate. Now we want the annual rate. So to do it in the annual rate, instead of doing this e stuff, we have to use the 1 plus r we've been used to. So we write e equals minus 0.0759, e to the minus 0.0759 power, which they gave us, equals the 1 plus r. All right? Now, evaluate this 0.9629 on your calculator. Like I said, what I did on my calculator, I hit the second key, I hit the ln key, and then I put in negative 0.0759 and then enter. All right, that gave me this number right here, 0.9269. Now remember, they're asking us for the rate. Well, r is the rate, so then we just got to subtract 1 to get the r. All right, and then the same kind of thing, it wants it to a percentage, round it down and kick to a percent. Again, since they have the word increasing, right? Actually, maybe it's a little. This is what I've got this to 5 decimal places as a percent. We would move that over 2, right? So that would be 7.3 0.09%, but it said just 2 decimal places, so 7.31. Okay, now, then we got the 280, plug the 0.9269 back in. You know what, I got more time than that, so I have time here. All right, so next step, rewrite the equation. So this was our original equation, right? And they want us to rewrite it like this. Okay, so the 280 stays the same. Then instead of the e to a power, see how they got the 1 plus r? Well, over here in what we did, this is where the 1 plus r is, right? 0.9269 is the 1 plus r. So I put in the 9.9269, just like for the 1 plus r, and a t and a t. All right, so that's it. You look forward over here, there it is. Okay, last step, how many people will there be after 8 years? I'm just going to stick the 8 here in for the t. Right? I'm just going to plug this into my calculator, put the 8 in for the t, and that got me this answer. Okay, that is, here's another one we'll do here. I'm just going to kind of talk about this one a little more quickly. We won't go through nearly slowly. All right. The population of a town with an initial population of 43,000 grows at a rate of 2.5% per year. Create an exponential, so this time they're asking for the 1 plus r from the beginning. So 2.5% is 0.025, right? That's my r. So 1 plus r is going to be 1 plus that is going to be 1.025, right? Come over here. There's our 43,000, right? Times 1.025 to the t. Okay? Then each of these numbers, literally, you just stick in this number for the t, round to the nearest whole number, you'll get these. Now, the one other thing they want to do is then you got to pick the graph. Okay? So, looking at these, one, you see these numbers are going up, right? Population numbers are going up here. Well, so we want one that's going up. So it's not going to be this one. It's not going to be this one. Now, they're a little bit weird here. So I want you to know that what happens here is exponential curves, when they're going up, they curve like that. Okay? And you can see this one curves up just a little bit like that. This one kind of curves down. That makes it this one. All right, that's what I've got for this section. I hope you found it helpful.